So, in an experiment to prepare salt, a learner reacted 3.0 grams of magnesium oxide with 40.0 centimeters cubed of dilute nitric acid of concentration 2.0 moles per decimeter cubed. A. Write a balanced chemical equation for the reaction. Let me just erase this. So, a balanced chemical equation for our reaction. Well, we have magnesium oxide, A. We have our magnesium oxide reacting with nitric acid. This is an acid, and this here is a base. So it's an acid-base reaction, neutralization. And we know that for a neutralization reaction, we get a salt and water. So magnesium goes the nitrate to give us magnesium nitrate. Hydrogen, hydrogen goes with oxygen to give us water. Now, our equation must be balanced. Here we have one nitrate, but here we have two nitrates. If I add the two here, I balance out my nitrates. I also happen to balance out my hydrogens, oxygen, and magnesium. So the entire equation is balanced. This here is our balanced chemical equation for the reaction. Then, coming to B, calculate the number of moles of magnesium oxide. So, B, what do we know about our magnesium oxide? We need to collect data. So, we know that its mass is 3.0 grams. We also know that its molar mass is going to be 40. In case you're wondering how we got this 40, we have magnesium oxide. One atom of oxygen has a mass of 16. One atom of magnesium has a mass of 24. Total mass of the oxygens, 16. Total mass of magnesium, 24. Adding it all up, we get 40 as the molar mass of magnesium oxide. Rather, since it's molar mass, 40 grams per mole. Now, let's get on with our calculation. We know that number of moles is the mass over the molar mass. Number of moles is the mass all over the molar mass. Number of moles is 3.0 divided by 40, which is 0.075 moles of magnesium oxide. And that's our solution to B1. Moving on to B2. be 2, we're required to figure out the number of moles of dilute nitric acid. What is our data? What exactly do we know about this nitric acid? Well, we do know that it has a concentration of 2.0 moles per decimeter cubed. That's the concentration, or the molarity if you may. And we have 40.0 centimeters cubed of our dilute nitric acid, which is our volume. 40.0 centimeters cubed. So, how do we link these two to our number of moles? Well, we know that our concentration is the number of moles over volume. You can write it as number of moles is concentration by the volume. So the number of moles is the concentration, which is 2.0 moles per decimeter cubed, by our volume. Notice that the volume is in centimeters cubed, and this is in moles per decimeter cubed. So you need to convert volume from centimeters cubed to decimeters cubed. And we do that by dividing the volume in centimeters cubed by 1,000. Then we get our number of moles as 2.0 times 0.04, which is just number of moles is 0.08 moles of nitric acid. For the final question, determine the limiting reactant. So we have two reactants, magnesium oxide and nitric acid. When the reaction takes place, either one of them would deplete before the other. So say magnesium oxide finishes first. It means we don't have any more magnesium oxide, so the reaction won't continue, meaning magnesium oxide was the limiting reagent. It's what stopped the chemical reaction because it finished before the other reactant. Assuming nitric acid is the limiting reactant, it would mean that we don't have enough nitric acid to react with magnesium oxide. And what that means is this is going to finish before this does, so we're going to have this left in excess. And that's the entire concept of a limiting reactant. So let's figure out what exactly is our limiting reactant. We just figured out that we have 0.075 moles of magnesium oxide. C. We just figured out that we have 0.075 moles of magnesium oxide. Let's do it both ways, magnesium oxide and nitric acid. We have 0.075 moles of this, and here we have 0.08 moles of this. So from this, what do you think is the limiting reactant? You would be tempted to say magnesium oxide since you're seeing less moles of magnesium oxide. So it makes sense that magnesium oxide would deplete before our nitric acid. Well, you may be right, but there's no guarantee. The only way you can be sure is when we compare our stoichiometric coefficients, which are these numbers here. This number here, there's no number here, that means there's a 1 magnesium oxide. Here I have a 2, here I have a 1, and here we have a 1. So go and compare the stoichiometric coefficients for all reactants. We have a 1 here, so we are going to divide by 1 to get 0.075 moles. The reason we divide is because these numbers tell us the ratio in which these reactants need to be for them to completely react. So here we're going to divide by 2, and we're going to get 0.04 moles. So we notice that this is less than this. So that means our limiting reactant, or LMR limiting reactant, is nitric acid. So the nitric acid will finish before the magnesium oxide, making it the limiting reactant. This is just about as much as you should know. Everything I say after this is just some extra information. So, why is nitric acid the limiting reactant? Well, look at how many moles of magnesium oxide we have. 0.075. If we want this to react with our nitric acid, we need the nitric acid to be in double that amount. Because we can see here that for every mole of magnesium oxide, we need 2 moles of nitric acid. So if we have 0.075 moles of magnesium oxide, for it to react with nitric acid, you need twice that amount, which is 0.150. But you don't have that much nitric acid. That's why nitric acid ends up being your limiting reactant. Yeah, and that's enough. That's the entire question solved. Hope you enjoyed the video.